think about read only, yes, you can't edit. Time variant, yes. So according to the time variance data you can find with the time parameters. And non-volatile, yes, you can't change it. The data, yeah, it's there, you can't edit it even. So those things are integrated. So very easily you can find this one as correct. Okay, Induvara, all right. Why did you select? Why didn't you select C? Iromi, sorry.
I actually didn't remember the properties properly.
Oh, Akna. All right. So that means you have to study about it if you can't remember. So we have to here. Okay, and then all right. So those things are available here. Yes, types of databases in an organization. So we have these databases, like data warehouses, we can call them as well. Okay, in the book, I think they refer to them as data warehouses because data mart is also storing all the data in the department wise, and you can see the data marts. Not in this one, no? Yes. Okay, this is having the online transaction processing systems, and then you have the staging area where you get the data here, and then some of the data you can send directly to the ODS for retrieving purpose and take current decisions regarding what is happening there. So otherwise you have the staging area where you carry out ELT. Okay, what is ELT? What is ELT? Sorry, huh? ETL. What is ETL? Hello? What does ETL stand for? Okay, you know about it. Thank you, Iromi. Thank you, Lakshima. Yes, so you have to carry out the ETL functions, and then you will be sending the data to the data warehouse. Okay, and meanwhile you will store them in the ODS for current data for retrieving and for, in order to take quick decisions regarding what is happening there. All right, and then you have to, when you have the data warehouse, you have to send the data to the data marts. Yes, so the data marts are here. Okay, so the data marts, in this case, they are here, but in some cases you can have data marts after this. Okay, so in this diagram, according to this diagram, this architecture, we have the data marts after the data warehouse. So then the data warehouse get the data, it shows all the data in the company organization, and then you have to sort them and save separate data in data marts. The subject wise you save them in the data marts. So we can, here you can find subject wise data in the data marts. So that is for easy retrieval purpose, and also we can prepare reports only based on that. Okay, so that's why we have data marts there. So all these things are explained, and you can see the data marts here and different types of data marts available. Okay, so here we have the data marts as independent data marts and dependent data marts. Okay, you have the independent and dependent data marts. Dependent data marts means you have to depend on the data warehouse. Independent means you don't have any data warehouse here. Okay, no data warehouse. Okay, So that means this is some for small and medium type organizations. They don't need to have a data warehouse. They don't have large number of data nodes. So then they can easily go with data marts. Data marts with the department wise, the finance department, then the HRM, they might be having separate data marts for storing their records. Okay, the sales records, sales and marketing, and then HRM, let's say, finance and accounting. So they will be storing their data in separate data marts, department wise. Then after that, these data needs to be sorted out, and then subject wise for analytical purpose, for taking the report, generating reports, we can further analyze and place them in another set of data marts. Okay, subject wise we can analyze and then categorize according to our requirement, according to the company requirement, and save them in the independent data mart. So these independent data marts, you can see that this data mart is receiving data from this one and also from this one. Okay, so then that's why, so you can see that we can get the data from this and then combine them and have them here. Let's say for the salary details, then you have to conduct get the data from HRM and also from the finance, okay, for extra earnings and all that. So then you have been saving them in a different data mart. So likewise, those things are independent data marts because they do not depend on a data warehouse. That's why. So you can remember it that way. Otherwise, it depend on some other data marts. Yes. Dependent data marts are always depending on a data warehouse. So you don't get data from any other source, but you have to depend on the data warehouse. So once the data is here, then you have to run the queries and then take the data to the data marts. Okay, so I just explained this one because some of the students said that data marts were not explained. Okay, that's why I just spent time. Otherwise, all these things are explained in the video. Yes, so this one, what is the answer? Everybody please. I have received one answer now. Very good. Let me see it. Yes. Oh, Hiromi. Good. What about the others? I have two replies. Which of the following is are correct regarding data marts? I am asking about the correct statements. Not incorrect ones. I am asking about the correct ones. Oh, so I have all the answers here. A, C, B, E. My goodness. So bad. Okay. I think I have it here even, or else I might have described it. Can't remember. Okay, let me see. Maybe in the video I have described it. Okay, I will tell you. Yes, here, Hiromi, you are very good, nah? You answered quickly and then the answer is correct. Niroshanathan, yes, you're partly correct, but you have answered provided two answers now. And then there was another one, I can't see the name, 532, you are correct. Yes. So now, here, data mart is a large repository of data collected from different sources. This is what it says in the first one. Data mart is not a large repository of data collected from different sources. This refers to data warehouse, not mart. Okay, data warehouse. And data mart can have data from all departments in an organization. This is also not about this, that's about data warehouse. Design process of a data mart is complicated. No, this is not. Why? Because the data mart is a simple database. It's just a simple database. You know how to design a database. It's very simple now. For a department, it's very simple. You just consider only a department because I told you earlier that it is data mart is connected to a department. So then designing a data mart is very simple. Okay, so it's not a complicated process. So this is also not correct. This is referring to data warehouse. And so this is a quality of a data warehouse, not a data mart. Okay. And compared with data warehouse, a data mart takes more time for handling data. So this is not more time but less time. This I told you, no, for handling data it has less number of data and then you can easily get the data. So you can easily save the data as well because you have less number of data there and you are talking only about a particular subject, so particular topic, particular department. Okay, so when you have the data mart connected to a company, connected to a department, just like data mart connected to a department, okay, like this one, So you have to consider only about that department of the organization, just the department. So this is for one department and this is for another department. This is for another department. But this one is having all sorts of data. So this is for designing a data warehouse is very complicated and complex system, complex structure is there, and you need to take more time for, and then everybody should agree with having data there, and then likewise it's very time consuming and also yes takes long time for designing and it's complicated. But designing a database like this, it's a mart database, okay, so it's very easy for anybody to develop a data mart. And then again for this one even, this is also for subject wise. So as I told you earlier here, just subject wise you can collect data here and then you can mixture of that will be placed here for easy generating of the reports. So then this one is having a very simple structure and it takes less time for designing. Okay. So then what is the answer? The E, a typical data mart can be implemented in few months. Don't you think that it cannot be done? Huh? So even if you develop a database, or you are developing systems, no, even the systems you develop in months, no? Okay. So one semester, the third years, they develop them in 3 months, 6 months, and then you just talk about the data mart is not few months even, very easily you can develop. But for months you will need, because you need to gather data requirements properly and then analyze it and then test it and test it out and then implement it. Okay, this is about implementing. Okay, hello, where are you, hello Shamodi.
Hello, madam.
532. May I know your name, please?
I am Sumaya, madam.
Shumeya.
Yeah, Sumaya.
Okay, Shumeya. Dumidu. Hello.
Yes, ma'am. Hello. Can you hear me?
Sorry, I got disconnected. Let's move to the next one. The quiz 4. Can you hear me? Hello?
Yes, madam. We can.
Okay, thank you. Now you know about data marts. I just gave you lot of questions regarding data marts and data warehouse, because uh, I came to know that in the other course they do not cover data marts. Now next time we'll be developing these databases, the next week. All right, very good. Yes, all of you are correct. Now you know about it. Very good. All of you are correct. Yes, the answer is D. Okay, thank you for the answers. Yes, answer is D. Then we have the enterprise data warehouses. They are warehouse when you talk about the whole enterprise. The enterprise data warehouse is considering the connecting all the systems in the enterprise, the organization. So we have the here a data warehouse. Yes. So that I have given you the qualities of it, and it's a large scale data warehouse and it integrates everything. Okay, all the data, and you have different types of systems connected to it. Okay. Yes. And then I have asked you to compare data marts and data warehouse. Okay, so then with this now I think you can do this one. Yes, then we have the operational data stores. Operational data stores, I told you earlier, but if I explain you further, now it provides, now you can see that this is the one actually connects quickly to the TPS, transaction processing systems. That's why we have operational data. Okay, can you see this operational data? So we need the transactional processing, the all kinds of operational data to be collected to a database. Why? Because when you have a data warehouse, it takes time for collecting and storing, and also we have all kinds of historical data here. And for the easy analytical purpose, we need another system, another database. Okay, another database. Why? Because then we can easily find the problems in the current data with the what is happening right now. People want to know about it. The banking sector, sales and marketing, because people are using a lot of credit cards, okay, for buying and purchasing. Yes, so now we need a operational data store for that. Okay, so that's what we call it. Yes, so that one is storing all sorts of operational data, and then we prepare near real-time reports. Okay, so what is happening just now, so they can prepare reports. But this data is actually uh, current data. Okay, current data means now somebody do a transaction, so they enter data and they do some editing as well. So all this data, that is volatile data, current data is there. Okay, then this one is updated throughout the business process. Why? Because people are doing changes to it, editing, updating, all sorts of things are doing. So then the current data is there, and then the this data gets updates. Okay, so this is good for taking decisions, for short-term decisions. Short-term decisions, what is happening right now, what should be done now, whether to hold, whether to do some changes to the process, whether to what just now in the what is in the process line, do we have to do some changes, so that means to stop some processes immediately. There's an injury, let's say, there may be a fraud detection, or let's say we have to stop the transaction. So likewise, you have to take immediate decisions. Okay, so this is decisions are involving with mission critical applications because of that. All right, so that's about ODS. Then yes, where is my and then with this one also you can you need a lot of models in order to carry out this data, so you can take the data in the organization as well in order to conduct the operations analysis part. So then you have the metadata, you know about this. So this is about data of data. I think you know about it, because according to my experience you know about this. Yes, so there are three types of data: syntactic metadata, structural metadata, and semantic metadata. So these things are also explained in the video. Please refer to that. And then the data warehouse, you have the structure. Okay, you have a data warehouse structure and the data warehouse process, so depending on that, and the middleware tools, then the ETL process. Okay, so then we'll be talking about ETL process in general. Okay, that is the mostly used one, but there's another one as well, ELT process, that we'll be talking about that one as well next. So here this one you know. Okay, if you have any questions you can ask. So then the ETL process is there, and then you have the data warehousing architectures. There are different types of architectures. You can use 2-tier, 3-tier, but 3-tier is the heavily used one. Okay, the best as well. Why is it that? Why do you think that 3-tier architecture is best? Hmm? Can you write that in the point form? Why do we say that three-tier architecture is best for uh, our data warehousing environments? Any more answers, please? Now, you have to compare two-tier architecture and three-tier architecture. Then only you can say why three-tier architecture is more appropriate. So when you compare the two architectures, you can see that there's a difference. Okay, so there's a difference. What is the difference? What is the difference? So you have to have a middle one. There's a middle one. Okay, there's a middle part, middle layer. So this middle layer is about application servers. That means all online analytical processing servers are there. Analytical processing servers are there, placed in the middle layer for the data warehousing. Okay. So when you talk about data warehousing, so when we say why we want to have a three-tier architecture for data warehouse. Yes, security is one aspect. Security is one aspect. And again you have to talk about the qualities of this one. Okay, having a separate layer for this one. Oh, sorry, got disconnected again. Power failure. Let's see. This is difficult to be done. So here, can you hear me please?
Yes, madam, we can hear.
Thank you. Yes, now you have to refer to this, the middle tire, and then you have to explain. You have to explain the importance of it. Yes, security is one aspect. The other thing is actually, since you have a separate layer for analytical part, you can do that work with maximum, with more efficiently. Okay, we can do the analytical part more efficiently, and lot of work can be carried out there, and without disturbing the whole set of other data. So you can carry out all analytical part here very well. So we need to have, it's good to have a three-tier architecture for data warehouse. Yes, so this one I have explained here. So you can see that we can have the online analytical servers, okay, and we can have them as relational or multidimensional, okay, and this will become a mediator between the end user and the database. So here again you can see that this middle part, this whole thing, the OLAP server and the data warehouse servers. So you can have the, sorry, I just wrote incorrectly, this one. And these two are for the data source. This is for the data source, and then this is for the bottom layer, okay, data warehouse. I cannot see this properly, that's why. The tools are covering the interface. Yes. All right, here you can see the application layer, okay, so the people are accessing the system front end, and then you have the middle, the OLAP server. So this is the OLAP server here, the middle tier. So you can see the multidimensional or relational you can have here, okay, for analyzing analytical servers. And this analytical purpose, it is better to have a separate layer, so you can carry out all these analytical work more efficiently, and then we can get the data from here, from the bottom layer, and these are from the data sources. The data sources, we have external and internal data sources in the organization. All these things can be taken to the data warehouse, and you can carry out the analysis here. Okay, that's about it. Yes, and then I have explained that one further using another diagram here. Okay, so this part we have to talk here with the business analytics. We have to talk about this report generation and the analytical part. Okay, in the BI we talk about this report generation and the analytical parts a lot, but the rest of the things you need to have a basic understanding about, because otherwise you can't do the work properly. The data marts, if you think about the architectures in the data marts, usually you can have, as I showed you earlier, different types of architectures can be there, dependent and independent data marts can be there. And if you think about this one, here you can have a bus architecture where you have the lot of data marts connected to the source systems, like coming from the departments, okay, different departments, and then when you want to analyze the data, you will have them in the separate data marts, okay. There you can have the different structure, Okay, but this one may be different from this one. Because why? Because we collect data from this and place here, and also we will collect data from here, and sometimes from this one as well, and also you'll get data here. Okay, likewise you will sort them and then put the relevant data here. Okay, so machine data for the analytical purpose. So then this one is for analytical purpose. So this is a bus architecture where you have the ETL process carried out in the middle. Okay, the staging area. Yes, here. So then again, I have talked about here in the hubs and the spoke architecture. Here you can describe that one as well. The hub is connecting everything, and then the spokes are there where you connect the other connections. So this is also explained. It's about data warehouse, not about marts. So then you have to refer to the video for more information. So we'll go to the next one. The next part. I'm taking more than 1 hour, no, today. I should not, I believe. Part 2. This is about part 2. This set of videos are already uploaded, and then I'm asking about what direct benefits can be expected by having a data warehouse at an enterprise. Okay, so then these things we have discussed already. Okay, end users can analyze data extensively in numerous ways for enterprise purpose, different purposes, and possible to get a consolidated view of corporate data at any time, access to better and more timely information, and likewise, okay, information processing can be carried out in low cost servers, allowing to process thousands of users. So these kind of information are there, we have already discussed. And then this system will perform better, and the data access is simplified. Okay, so that everybody will be able to access data from one particular place. So then this is what we talk about, the advantages of the 3-tier architecture. So you have to answer that question as well. Okay, most of these questions that I have in the slides are connected to the examination questions as well. So you have to find answers, otherwise you will end up with a problem of not being able to answer the exam properly. Yes, so now data warehouse design, this one I told you earlier as well, but you can see that we have often we refer to this architecture. Can you see this one? So this is the top-down approach. Okay, top-down approach means from the top, the data marts to data warehouse, you will get the data, and then from the data warehouse to data marts, you are sending the data. Okay, then you will be getting from the data mart, data warehouse, we will be analyzing analyze the data, and then we will sort them and then send them for storing purpose, and then the for this BI applications can be run at this place and also at this place. Okay, so we have to refer to this part. So now for data warehouse designs, Bill Inman says that this top-down approach is supporting for the people to store data in the data marts after storing them in the data warehouse. So then the source systems are storing the data, that means the transaction processing systems are collecting the data in their databases and then sending them to the data warehouse. The data warehouse is sending the data to the data mart, so that we have to run the ETL processes. Then you have to retrieve data, the queries needs to be run, and then you have to get the data to data marts. So you have to separate the data and put them in the data marts. So this is a top down. So because from the data warehouse to data marts, top down approach. If you think about the bottom up approach, then this is the data warehouse, because we are talking about the data warehouse. So the data warehouse should be on the bottom. Okay, bottom up approach, data warehouse should be on the bottom, and then from the bottom you can see that data marts are placed on the top. Okay, so this approach. So this approach, you can see that you have to collect the data to the data marts first. Can you see that earlier I said that you will be getting data from different departments and saving them in data marts? So that's it. Okay. So I told you about earlier that even without having a data warehouse, you can save the data in data marts. So this structure says that from the source of information, so that means the transaction processing systems, any kind of operational systems, whatever the systems available in the organization, can store their data in the closest database. That means they are data mart. Okay, that they will be saving their data there. Okay, but again you can run some ETL functions there, processors, and then save them in the data marts. So anyway, first you will get the data to the data marts. Then you will be running the ETL processes again and then placing them in the data warehouse. So this is about bottom up. Why bottom? Because data warehouse is on the bottom. Clear to you? Hello?
Yes, ma'am.
What about the others? Oshi. I didn't see your name. Oshi, are you there?
Yes,
Oh, good. Piumal.
Yes, ma'am.
Tisara.
yes, madam.
Good. Okay. Any questions? Did you understand this one? Billmon and Ralph Kimball's approaches. The Billmon said this, and then Ralph Kimball says, oh, they can have this and as well. Okay. Different purposes. They have different objectives. So people who wants to find some more information about their closest department, they like to want to have Kimball's approach, bottom-up approach. Okay, so that they can get the information very quickly. So when you have large organizations, so it's when you collect the data to a data warehouse and put them in the data marts and start analyzing, it takes some time, and then you have to always deal with the historical data. But this structure is supporting for retrieving data fast, the bottom-up approach. But if you think about the today's structure with the ODS, so then we have the operational data stores are there. Yeah, we have with the online systems, that structure has come. Yes, that solution has been implemented for the all type of top-down approaches. Yes, now I have compared them here as well. These things you can refer to. Yes, I have detail with more tables. I have explained this. So you can think about Inmon and the Kimball. Building a data warehouse for the Inmon, it takes long time. Why? Because you have to first start developing the data warehouse, then you have to go for the data marts. But the Kimball's approach is talking about data marts first, so that takes lesser time because you can start with developing data marts and then easily you can combine them and put them in the data marts. So that takes lesser time as well. And then the maintenance wise, inbound approach is much easier because you have this one centralized data warehouse, and then you have to maintain only that one. But the Kimball's one is difficult when you have some more departments. Let's say you need to have another data mart or connect that one to another data mart. So sometimes that that department needs to be connected to two data marts according to the structure you have applied earlier. So then it is very difficult. Okay, so, and again there will be often redundant data subject to revisions as well. So you can't, you have to always go back and improve the data marts. The cost wise, if you think about the cost wise, the in-months approach is the initial cost is high, um, but subsequent project development cost will be much lower. Okay, so you can think about the initially you have to spend a lot, but later the project development cost will be much lower while you have the system there and you have the database there, so you can do the steady improvements there with the project. You can run the other projects with that. The Kimball's approach is opposite, but actually because the low initial cost, that's a low initial cost, then the next improvements will also cost the same amount. Okay, so then compared to low initial, with its initial cost is high, but then the same amount needs to be spent for the later on improvements, the work that we carried out. Okay, so the comparatively will be higher. The time takes up, this will take longer time, and then Kimball's approach will be shorter time. Why? Because of the structure, the organization, that the architecture that we have there. Because we have the data marts first, so that we can quickly go on developing it and then implement it very quickly. Okay, and also we can work with some kind of technical experts who are not necessary to be experts. Why? Because the people who know about developing a database, how to handle data, might be able to develop it, start developing it. Okay, but for in-months approach, because you have to consider a lot about developing that, and everybody should agree with sharing their data in one platform, one system, one database. Okay, so you need to have a specialist team, otherwise there will be a big problem. Data integration requirement, this is enterprise wide, but this one is individual business area wise. You can have the Kimball's approach. Okay, it's supporting for having data warehouses. All right, what is the answer for this one? Now you should be able to answer very quickly. What is the answer? There are two answers for this. Okay, so now it's easy for you. Two correct options are there. Not two answers, two correct options are there. Everybody please make an attempt. It's good if you can make mistakes even, so that with the mistakes you can learn better. Okay. Adopting bottom-up approach to data warehouse design. Adapting adapting bottom-up approach. You know that bottom-up approach, the data warehouse is at the bottom, and then you will have the data marts on top of it. So then we will be developing the data marts first, and then we'll go to the data warehouse as well. When you develop it, you can focus more about developing the data marts first, and then you can combine all this data and then put them in the data marts. All right, now what is the answer? It's 9:30, no? You have to stop now. Yes. Hello. Okay, now I am going to give you the answer. Yes, most of you have written one answer correct. Yes, A. A is correct. Yes, all of your answers are correct regarding A. And then some of you have written D. D is about having consistent data. And then the other one, some of you have written C as a correct answer. Easy maintenance. Maintenance is easy. How can you say that? And then you have B. Okay, we'll see. There. This is wrong. Yes, you can easily get that. Yes, you can't get an enterprise view. Yes, because you have only a particular data mart first, and then you have the data warehouse next. That means you're talking about smaller organizations. Yes, having consistent data. Can you say that consistent data will be there? How can you say consistent data will be there? Why? Because now I told you, no, because when you have this structure this way, yes, yes. When you have this structure, you will be having one day the employee number may be here and also here. The sales number, sometimes the employee number, let's say, then the ID number, sometimes something like that. So all kind of maybe duplicates are there. It's not be consistent. Okay, so then the consistent data will not be there. But this one, yes, you will be having consistent data. Yes, so this answer is not correct. Having consistent data, because here we are talking about the bottom up approach. So you can't have this one. Then the easy maintenance. Maintenance is easy. No, I told you, no, when you want to do some changes, it's very difficult because first of all, you might have thought of designing the data marts connected to other systems. Then later on, if you implement a new system, then you will find it very difficult to maintain it. Okay, for in linking that system to the existing data marts, so very difficult. So then easy maintenance is not correct, but for the in-months approach, it's correct. But for the bottom up, that means the Kimballs, this is wrong. Okay, so this is also wrong, this is also wrong. Now, low risk of failure. Yes, why? Because you have the when you implement it, when you trust implementing, you will have something very quickly and you can develop it. So you have the system data marts there. So then the risk of failure is very low. Why? Because the data warehouse, the projects, actually there is a huge risk of failure, because sometimes we will not be able to get what we want to do. Okay, but for the data marts, one by one we will develop and then go on, then we will be able to do something very quickly, and also the risk of failure will be very low, and the lesser time for development. Yes, so then these two are correct. All right, clap hands for those who answered correctly. Okay, Niroshanathan, very good, huh? Tisara, okay, good. Hiromi, very nice. You can see that Chamodi. All of you are good. Yes. Thanks for the answers. Very nice. Yes, then we need to know about the data warehouse design process. Okay, so then there is a design process. So this needs to be followed. Now next time when we develop the data warehouse, I'll be asking about this from you. So you have to know about it. Okay, so next week I'll be using, as I told you, QlikView software and develop a data warehouse. Okay, and also a dashboard based on that. So then how to connect it, develop a data dashboard using data warehouse. Yes. So for developing a data warehouse, you might be using for the database structure. You have basically two, the data star scheme or the Snowflake scheme. Do you know the difference between these two? Hello? Tisara? Induvara? What is the difference between these two? Snowflakes and the, yes, star scheme. What are the differences between these two?
In Snowflake, the main table is like linked to other tables, and each table has relationships between them. But then in star scheme, all the tables will have relationship with only the central data table.
Very good. Okay. What else can you say? Others, can you contribute to this discussion, please? Sumaya, Madhavi, Sandamini, nice name. Akna, Hansika. Today you didn't answer, no? Hansika, very silent. Hello. Okay, if you think about the normalized data, where can you find normalized data? In the star scheme or in the snowflake scheme? Okay.
Snowflake.
Yes, good. Okay, you know about it. Very nice. Okay. And then the new data warehouse architectures are there where you have the cloud-based data warehouses. Okay, so you have the Google BigQuery and Amazon Redshift. These cloud-based data warehouses also needs to be studied, because now you can see that these systems are supportive for accessing even by you for your work. In if you want to access and use this kind of infrastructure for analytical purpose, then you can use their infrastructure. So this data warehouse has a unique, but the different types of data warehouses, that means the big Google BigQuery, or if you take a Redshift, they have different architectures. Okay, so that not like common data warehouse structures that we said, but you have mapping from that to this as well. But based on that, they have developed these things, and those architectures are different and unique for those particular systems that they have developed. Okay, now then you have to think about their functionalities. Then if you think about the benefits of using cloud-based data warehouses, is that you don't need to purchase the physical hardware, because those things are available, and then you can access them and then use them, and you can make the payment for the rental payment, let's say. That means the monthly payment or yearly payment needs to be done if they want you to pay, because if you want to store a lot of data there, then you have to make a payment. Otherwise, for a smaller space, then they will allow you to free access the space. But anyway, the accessing the content in that servers are very easy, and also fast, very fast. You can quickly access the data, and the cost is also comparatively cheap. Why? Because otherwise you have to implement it, maintain it, so it's very difficult. And then having access to a cloud-based data warehouse would be much more convenient for the organizations, new startup organizations. But for well-established organizations, they might not like to share their data outside, and they might feel like protecting their data. So they want to develop their own data warehouses. So they will need your support for developing them. Okay. So anyway, these systems are supportive for massive parallel processing. That means the parallelly you can carry out processes in different systems, different platforms, because you might have large number of data marts, large number of data warehouses, even coming from the before coming to the centralized data warehouse. So then you can see that large number of processes needs to be can be carried out at a time. So we can call it as massive parallel processing. Okay, so then these things are typically complex, and then things are very fast as well. Okay, so that's how they will provide you the support very quickly. Yes, now you can compare the cloud-based data warehouses with traditional data warehouses and see. Okay, so this is an exercise for you, so you can read further about this and then learn about Redshift and then the Google's data warehouse, and then find more information about their features. Yes, so then again I told you earlier that there is ELT as well. Okay, ELT, you have heard about ETL a lot. Okay, where you have the extract, then you have the transform the data into correct structures, the patterns, and then you have the load it to the analytical purpose. Okay, so then you have the ETL process in the data warehouse. But when we talk about data lakes, so especially when we talk about cloud-based systems, we have data lakes there. Okay, so then we have to talk about ELT process. So there you have the extract and then you load and then transform. Why? Because you have to put them in a data lake, and that is for loading, and then you have to distribute them to the correct organization for transforming. Okay, yes. So then first of all, since you have large number of systems connected to data where this system, large number of systems are connected to this data warehouse, you need to get the data very quickly. Okay, so you can't wait for transforming. So what do? We just replicate and then put them in the data lake. Okay, you have to load them very quickly. Why? Because you can't wait for transforming. Again, it's because we are connecting, especially when you go for cloud-based systems, you have large number of systems connected to them. So we have to get the data very quickly and then support the services to the customers. That means at the other organizations. So then you have to load them very quickly. Get the data to a data lake. You get the data here by replicating all this data here, and then you have to find what you need to do with this data. What do you need to do with this data? So accordingly you will send them, okay, for different purposes. Okay, so that can be done next. So that is about transforming. But here you can see, when you have the earlier, the transforming is required. Why? Because we talk about internal organization. Within an organization, we will get some data and you want to transform them, and then you have to generate reports for one particular reason. Okay, so that means for the executives to take decisions, for the senior managers to take decisions. But now we have different requirements. Alright, so that's about it. And then we have a comparison of data lakes and data warehouses. So where you have the data lakes, you have the raw data. Okay, if you think about the data warehouse, you have the process data. Why? Because data lakes, you are duplicating and replicating the data and then just collect the data there. Okay, and this is for cloud-based applications. Okay, and data scientists are working with data lakes, and these are highly accessible to and quickly you can update. Okay, so you have to compare these two. You should be able to know about data lakes a lot, okay, today, because we are heavily using cloud-based systems. So read about it for information. And next we have to talk about the business intelligence front end development. Okay, now data warehouse has four components. One is that front end development component in the business intelligence systems. And then there you have the business query and reporting tools and production reporting tools. So these two tools needs to be known because we are going to create the reports. So that is also explained in the video. Please refer to it. I have uploaded all the videos now. Now I have taken almost 2 hours. So that's not good actually. Yes. It's okay for last week I didn't take any time now. Okay. I think it's all right. All right. Hello. Now you have work to do. Okay, if I remind you again that you have to go to the online course environment, and even if you have too many assignments, if you do not do this one, then you will end up with a problem. Why is it that if you do not do these activities, you will not be able to do the activities next time, because when I am going to do it, you will not be able to understand it, because I am going to start the practicals. The ClickView will be started next week, and then we will be having the other applications in the coming weeks. So you have to go to the online course environment and then do the activities here. Okay, so you have to create the dashboard using the Tableau. That one I have given here, the instructions and the video you have to watch and do it. The data set is available here. Just follow the steps and do it. Take 1 to 2 hours. Okay, maximum 2 hours. And then for the Power BI also you have a video here and also a data set available here. It's a nice thing that you can develop it very quickly, and you have to install the Power BI desktop version, okay, because this is required for the practical sessions on the 5th of November as well. 5th and 6th both. Please keep the days reserved tentatively. And next you have to download the ClickView, okay, for the next week. For the next week, please download the ClickView and then download the ClickView Personal. This one I have given you the link. This one you have to download, and then get ready for the practicals. Okay. Do you have anything to ask or you can tell me anything? Nothing? Then I am going to end. Bye. Hello, can you hear me?
Yes, madam, we can.
Okay, I'm going to end if you don't have any questions.
Okay.